Here we go. I'm in the middle of Mass Effect Andromeda, and first of all, quick commentary on the game. I never actually played this when it came out for several reasons. And first one is I never played Mass Effect 3. I did play Mass Effect 1 and I did play Mass Effect 2. In fact, I was at the E3 presentation when the first Mass Effect was shown off, and I still remember leaning over to my editor and going, "It's just a third person shooter. What's so special about it?" It's a statement that I still stand by years and years later. There really wasn't anything special to Mass Effect. In fact, it was actually a very thinly cloned copy of a different game, which I'll get into in a different post. But that's basically another story. One of the big issues I ran into is it was buggy. It was a BioWare game, and it was as buggy as a Bethesda RPG. And Fallout games, the Fallout 3, Fallout 4, Elder Scrolls, all of those are really known for having game-breaking bugs, and Mass Effect was... on Twitter, I kept getting Bethesda and BioWare confused, especially from a technical detail, because they just break so many things so many times where a lot of players, and I'm not sure the wrong, say you can't really play those games without modifications because the games are broken from the start. Well, here's kind of some, I'm not sure they're wrong, because I have successfully, I'm not running any mods, I'm not doing anything crazy, I've found a path out of the map. I'm in a map location, and so I'm tracking, pull up the scanner. I've got this yellow wire going up there. I've got this yellow wire going up here. And from where I was when I last tracked this, this is something that really bugs me about this game. This is not Metroid Prime scanning. All right. This is not as intuitive nor as smooth. If you want to know how to how to implement scanning in a game, Metroid Prime, the Prime games are your go-to. That's how you do it. This didn't do it that way, and the Mass Effect Andromeda implementation of scanning sucks very badly. But anyways, so I'm over here. I'd followed. There was another wire down here. I was over here. I'm following this wire, and I look up, and from the angle that I'm at, I may have been back here. Yeah, I was back here at this for this glyph. And so I'm tracking wire up, and from this angle, it looks like that panel is accessible from the top of that pillar. All right, so how do I get up there? Well, I see a jump point there, I see a jump point there, and I see a jump point there. So here we go. The last time that I looked at the where the panel was at the top of that icon. So, and I did it once, and now with the added latency of running OBS, I may not have the control to do it again. All right, we'll try from here. Okay, there we go. All right, so from there, yeah, OBS is adding a frame or 2 second delay. I don't know if you can hear it, but my graphics card's fan is howling. Okay. All right, there we go. So we're up here. Click. No panel. Oh, there's yellow wire. Remember what I said about the scanning sucking? Yeah, it's not just the movement. It's not just you can be running. But then as I turn around up here, I notice, okay, there looks like there's a path out here, which I can jump through. And I can get outside the map under the ice. Now, since I really don't know how broken this is probably a good place to do a new save, manual save, and just see how much of this I can explore or not explore, as the case may be. Because one of the times I did this earlier, I actually found a research monolith and 3 containers that had been set in a place where it's like, while I was going up a gravity well, and I saw lights in the distance on a higher shelf and went, maybe I'm supposed to be able to get to those. So then I figured out there is a way to drop down in that map, and then you got some extra research and some containers as a bonus for having taken that particular trek. So, is this a mistake? Is this a bug? I can't imagine a normal game in which being able to get under the map is considered a player explorable area. And I've did streams on this before with like Horizon Zero Dawn, where I got to a place where I wasn't really sure I was supposed to be there, because I got there apparently far earlier than the game possibly intended for me to be there. Okay, so I'm not finding anything in here. But anyway, since I managed to make it here outside the map without having to do anything really stupid or ludicrous, no modifications, just the base game client running, and outside the probable areas where the player is supposed to be. The point of all this is, and this is the same, it's a generalized problem with gaming in general, and we're seeing it now with the Steam Deck, which, no, I don't have one. No, Valve did not ship me one, and no, even though I was one of the first eligible to purchase, my ability to purchase, I've not been sent a notification email yet. In fact, according to the Steam page, mine is scheduled for Q2 2022, whatever that means. Yes, I'm a little annoyed at that. But anyways, with the Steam Deck, we're seeing a thread that we've seen before from developers who don't understand the concept of a tool chain. And a tool chain is not just the application that's used to make your game. The tool chain is the application that's used from top to bottom to make everything that supports your application. And that's the support files, library files. And this was something where I, years ago, didn't really get the difference between the development toolchain and not until Warren, the original creator of the Mepis distribution, laid it all out, and how Mark Shuttleworth's Ubuntu was breaking the Debian toolchain. They were breaking the actual applications used to create the rest of the applications that are used to support the operating system and support the applications you use on the desktop. And breaking the toolchain is bad. Now, if you are running both Windows and Linux, and you're developing for both Windows and Linux, you probably have either a compiler that targets both Windows and Linux simultaneously, or you have 2 different compilers. Or you only have one compiler and it's only targeting one operating system and it's only targeting Windows. And here's the thing. If you're a developer and you have a single code base with a single graphics API, a single whatever set of APIs that works across multiple operating systems, and you compile to those operating systems which have entirely different binary formats, entirely different operating requirements at the same time, your compiler will probably give you warnings if something in your code is broke. It becomes exponentially more difficult to deliberately create broken code if you have to satisfy the requirements of two different operating systems simultaneously. This is why building for Linux and Windows simultaneously is such a big deal. It's not that you're building for the Linux market segment, it's not that you're building to sell to Linux users, is that you're building to an entirely different operating system platform with an entirely different set of criteria for the application to run. And if your application can run on both platforms from one compiler, then you can probably be very sure that your code is well written and probably even well documented, since you've probably had to both make sure everyone knows what's going on with the code. You've also had to avoid making any specific code to deal with a specific problem in one specific platform. E.g., for example, you have to make a specific workaround that works for DirectX 9 for those users who have DirectX 9 graphics cards. But if you had been targeting for both Windows and Linux at the same time, you would have had an OpenGL build, and instead of creating a workaround for DirectX 9, you could have just done a path to OpenGL and targeted those same exact graphics cards from one code base without having to make expensive and time-consuming workarounds. This is why APIs matter. This is why multi-platform support really matters from a development standpoint. It forces developers to put a little bit more effort to make it multi-platform, and way less effort than to fix problems that come from making it a specific platform. And this also makes it easier if you have to go back and bring your game to another platform. Games that are built for multiple platforms translate to newer platforms much easier. Engines like Unreal that were already Linux and Windows compatible easily went to Apple for iOS. They easily went to Android Linux. Just once you have a portable code base that is stable and well built. If you hear the sirens, I promise that's not me. Once you have all of those considerations accounted for, it becomes easier to one-shot a development cycle. That is to say, to get all of the primary items working at once. And that's something that, well, a lot of game developers don't do. BioWare's games, and Bethesda's games for that matter, are filled with bugs because they use very platform specific APIs and ABIs to craft their games, and then it's basically they're treating each new platform that they port to as a specific new platform with its own requirements, rather than having a general base that's already targeted to all those platforms. And that's why code quality matters. And we're seeing that with the Steam Deck, where there's a lot of developers, a lot of publishers who don't understand the amount of work that went into Proton to make games work on top of Linux. Gabe Newell threatened years ago that he would pay his own money, his company's own money, to bring PC gaming to Linux, whether or not anyone else liked it. And that's what Steam Deck is doing. That's what Steam OS is doing. That's what Proton is doing. They are forcing developers to confront the problems with toolchain development. And hopefully, in the development discussions over how do we target Steam Deck, developers are finding out that once they start targeting multi-platforms, once they start targeting Linux and Windows simultaneously with one code base that's compiled simultaneously for both platforms, they're finding bugs and errors, programming bugs, geometry errors, build issues that would have flown through in a normal production environment because they didn't have the kind of tools or feedback that a multi-platform development environment would give. And that's a big problem with Bethesda games, and a big problem with BioWare games is they may be massive, they may have attempting to do something big, but the foundation for making that product is so haphazardly broken, the final result can't help but be broken. I mean, this is a big map that I'm on, and there's no way that I know of, or at least was available, to do a geometry hole check in the APIs that this game was constructed on. There were in a different API that was available that would have worked on all the other platforms. But because there wasn't a multi-platform focus on BioWare's part, instead of using a simple utility to check the geometry for any holes, to do a ray trace path, the basic concept of this utility is it takes a ray traced sphere and runs it across every point on the map. And at set intervals, it pulses and then it records. You basically get a light map of every place where a light reached. It doesn't base on where the player is, it based on where the map is. So if you have a solid map, you know from the shadow mapping, I'm not sure that's the right term, you know from the ray traced maps where light should be or where it shouldn't be. And this helps developers find and plug holes in geometries. And okay, I am talking about a very specific tool used for a very specific simulation purpose, but it did run atop OpenGL. Now, technically, we're talking about a tool that was really made for movie studios who were constructing massive landscapes where you really don't want if you're creating a movie backdrop, you need it to be as picture perfect as possible, and you need your lighting to be as realistic as possible. So that's where you do need those kind of ray traced shadow mapping techniques to come and play. But that kind of tech was available for games to use. And a number of geometry holes could have been solved just by having that AI path through it. Yes, it would take a few hundred hours of computational. But if you're EA BioWare, do you really have problems laying hands on some epics or Xeons or what would that have been when this game was made? Opterons? No, you probably wouldn't have had much of a problem laying your hands on some heavy-duty computational equipment to run those kinds of checks. You just would have had to have your game run on a different API than DirectX. Anyway, so I know there's a few movie studio execs who are probably going, did you really have to talk about that? And going, yeah, it's a cool tool. I mean, seriously, it's a really cool tool. I mean, yes, I know it takes forever to run, but it's a really cool tool if you want to get your, if you're building a construction in an, to be rendered, it's a really cool tool for making sure that you've got every bit of geometry covered. Every bit of no holes in any geometry. And that's, and you probably already have an idea of which movie studio I'm picking on who has this tool. I don't think they've made an open source version of it, but it is available. There are, I think, are some alternatives out there that have somewhat of the same effect. But anyways, so that was kind of just while I was playing, I couldn't help but comment on how did this map hole break through. And part of it is players would probably not have found that if the scanning system was not an absolute train wreck. I mean, both in utility for moving, and kind of the reason I paused the game instead of trying to play it is you may have noticed during the jumps, OBS is adding a substantial amount of latency to my inputs. This system is not powerful enough to render this game, and the graphic setting is on and run OBS at the same time. So I'm going to cut OBS off and go back to enjoying this game.